Now we will present the OSPF. Um, the topology is like this. We have the R1, R2, and R3. R1, R2 connected by the serial interface. R1, R3 connected by the gig interface. Um, this just the one area, area 0. Um, we will before we start to configure OSPF, we will capture the data on this interface. Um, so it's R101. Okay, we will leave it running. So we will start to configure the OSPF. So OSPF, you will start to set OSPF process number and the router ID. Router ID. We use the loopback address 10.0.1.1. So you have to specify which area you plan to configure. We are applying area 0, and you have to specify which subnet you want to run OSPF. So network 10.0.1.0, wild card network 10.0.12.0, network 10.0.13.0. 255. Okay, now we configure R2. So R2. So OSPF process 1 router ID 10.0.2.2 and area 0 network 10.0.2.0 000.255. Network 10.0.12.0 000.255. So display OSPF pair. Okay, now we have one pair between R1 and R2. Now we can stop capturing. So we will see the data we captured. So here, when we start to configure R1, let's close this. When we start to configure this one, remember we configure R1 first, right? So on this interface, it will send the hello packets to 224.0.0.5 IP address. That's for OSPF. So it keeps sending hello packets each 5 seconds. You can see 5 seconds. Not 5 seconds, sorry. So 94 to 10 seconds. 103, that's the timing. 103 to 112, 112 to 121 is around 10 seconds. So let's see how that's the hello packets we send it here from R1. This one is the one we configured the R2. It start to send the hello packets. So let's see the 3 hello packets. and so when they exchange the information, they establish the OSPF pairing. So here's the three hello packets. So the first one, the R1, when you configure OSPF, R1 start to send hello on his interface. Source is 10.0.12.1, sent to 224.00.5, which is the OSPF. So all the OSPF router will listen to this address. So the second one is the when you configure R2, R2 start to send the hello is the source address 10.0.12.2, sent to the same multicast IP. So here you can see they don't have any, they don't hear anything yet. But the third one is sent from R1 when he received this the message from R2. It basically says there are some parameters they have to match. So when they R1 check all these parameters and they found that they're all match, they will say, okay, I found my neighbor. So it will says the active neighbor is 10.0.2.2. Last is the router ID we configured. So the next very important packets is called LSA, link state advertisement. So you can see from here is the send from R2. It basically says um, this is the router LSA type 1. So basically they have a type 1, 2, 3, 4, 5, and 7. That's the OSPF LSA type. So this one is the router LSA. Basically, is the router will tell his neighbor was the network connected to this router. So you can see the link state ID 10.0.22. Advertise the router is 10.0.22. So the next one is the R1 will advertise. It will send the type 1 LSA, or it's called router LSA. So in this advertisement, it basically will says the so basically it will says there are three networks connected on this router. So one is 10.0.12.0. The metric is how they calculate the metric is they use the 100 meg divided by the interface the backbones back so the bandwidth. So since this one is the serial interface, so 100 meg divided by 2 something, right? Uh, so that's where this number come from, and this one is the metric is 1. I guess it's the 100 meg interface, and this one is the local, so it's 0. So another one is the come from router 2. So router 2 basically says there are two networks connect to uh, myself. One is 10.0.12.0, same metric, um, because it's the serial interface, and the second one is his loopback address 10.0.22. So the other one is called link state acknowledge, which basically means to confirm that the router received the correct information. So to make sure the database exchange has completed. Now we check the database. By default, the router in the same area should have identical database. So that's how the OSPF works. First, the router will establish the neighbor or pair. After they establish the neighbor, so they exchange the database. So when they finish change the routing information, like they build a database, right? So each router will start to calculate. Um, uh, so each router will use itself as the root to um, calculate the path to all the networks in the database. And again, the router in the same area should have identical interface database. So this one show the command is display OSPF LSDB link state database. So you can see they have same identical database, and also you can uh, remember in the capture we can see the LSP is the LS type 1 is called the router, right? So router LSA. So you see here, we can see router here. So let's call the router link states. Okay, we put a router. You see here, that's basically the one is the link state ID is 10.0.2.2, which is the this one is R2 advertised. And this one is advertised by R1 10.0.11. So you can see so R1 basically advertise these three links. One, actually there's two networks. So one here, one here, and R1s advertise the 1, 2, and 3. So same thing here. If you check, if you type the same command, you should find the identical information. So you see there exactly the same information. Now we can display the routing information, protocol OSPF. So for R1, you learn 10.0.2.2/32, which is the R2's loopback address. And from R2, you run the same command, display IP routing protocol OSPF. You should learn 10.0.11, which is the R1's loopback address, and 10.0.13.0. Lets the network actually connect between R1 and R3. Now we can do the same thing on the R3. So OSPF 1 router ID 10.0.3.3 and the area 0 network 10.0.3.0.0.0.255 network 10.0.13.0.0.0 255. Run the network 172.16.0.0.0.255. Okay, now I display OSPF LSDB. You can see more, right? You see here, LSDB. You see they are all same, but each of them they covered more than one subnets. So display OSPF IP protocol OSPF. Now we learn R2, R3, and another loopback address from R3. So R2, you can specify the protocol OSPF. So from OSPF we learn R1's loopback, R3's loopback address, interface between R1 and R3, and another loopback interface on R3. So same thing here. Protocol OSPF. So from here you learn R1, R2's loopback interface and the interface between R1 and R2. So to troubleshooting OSPF, the first command is to check the OSPF interface. So you should see all the interface running OSPF. And the second one is to check OSPF neighbor, OSPF peer. So basically, this command will show you all the interfaces running OSPF, and for each interface, you should see the OSPF pair. And the third one is display the OSPF LSDB. The last one is check the routing table. So again, first you check the neighbor or the peer. Okay, sorry. So first one you check the interface, which is running OSPF. To make sure all the interface you want to run OSPF is there. So second, you check all the peer has been established. The third one, you check the link state database. They should be identical on each router. And the fourth one is for sure is to check the routing information itself. Next, we will present how to change the OSPF hello interval and the dead interval. In order to establish the pairing, the interface on each, this to see this interface, right? And this router and this router, on this interface, the hello interval and the dead interval should be the same. Otherwise, even all the other parameters match, they wouldn't be able to establish the pairing. Let's see what's the current interval. So display OSPF interface gig 0/0/0. You can see the hello is 10 second, died is 40 second. So see, they are same 10 second, 40 for that interval. So now we will change it, change the timer. So if we go to and we type OSPF timer hello, we change it to 20. You can see that now it's 20, this 10. Let's see the OSPF pair. Now you can see we used to have two pairs. One is R2 and one is R3. But now you see, because the hello interval is different, they couldn't establish pairing. I mean, the existing pairing will be broken. And let's again we change, and like you see this that interval. So by default, that interval is 4 times of hello. If you just change hello, the that interval will be automatically change. OSPF timer hello 20. Okay. Now you can see the pair was is recovered. So now we have two pairing again. Let's see the display interface. You can see 20 and 80. Let's see how if we change the that interval. So SPF timer that we change it to 70. But from my understand, it shouldn't change the hello. So let me see. Display OSPF interface gig 000. You see, that interval is 70, but hello is still 20. So which means if you change hello, that interval, if you don't change that interval, it will be automatically changed to 4 times of hello. But if you change that interval and don't touch hello, hello will not be changed. So here this is still 20, 80. We should lost the pair because the dead interval changed. It may take longer. What we can do is we can go. Oh, it happened. Now we lost it because the dead interval doesn't match. Let's change it back. OSPF timer hello 10. The same thing here. Well, this time the dead interval doesn't change. Let's see this side. This one change it back. OSPF 40. OSPF here. 1040. Oh, it's down. Okay, now we get it back. The next, we will present the how to configure OSPF to advertise default routes, and so on R3 we can set up default route, route static 0.0.0.172.16 The next one is 0.3, I guess. Okay, so this. Yeah, dot 1. 1.16.0. The next hop address is invalid. No, okay, I see what it. So we can only put like this. Loopback 2. Because the remember we said we tested before the static routes. So the default route basically is a specific static route. For all the static route, either you can point to the next hub IP address or the local interface. So in this case, we point to the local interface. Um, why we do this is because there's a rule if the OSPF want to advertise the default route, it must have a default route in its routing table. So you can see that's our default route. So you can see OSPF1 default route advertise. Before we do this, we can go to here to check the routing. So we don't see any default route here. So when after we start, see now here we learn the default route. Um, so basically what happened is this command will tell the OSPF process, I want to advertise a default route. Um, but there's you have to check your local routing table first to see if you don't have a default route in your routing table. Even you have this command, you cannot advertise. Let's see. Uh, so and do I static 0 0. Okay, let's see if we still have this. Okay, we still have this. Let's you see here. Let's see. We don't see any routes from R3. Yeah, we do have the pair. Okay, it's still advertised. So my understanding is not correct because my understanding came from Cisco. Let's see the local interface, the local routing table. Still there. Okay, that's why. And do static 0 0. Okay, now it's not there. Okay, so this one doesn't. So even let's see, we should still have that command under the OSPF. See here, the command is still there, but in the local routing table we don't have the default route. So this router even has that command, it doesn't advertise the default route. And that makes sense because if you advertise the default route, basically most likely the default route will be used for the all the traffic to like internet, right? So if you don't have a default route and you tell somebody else to say, okay, I know how to go to internet, but uh, you tell the other guy you know how to get that, but actually you don't because in your routing table, even yourself don't have the default route. So the rule is if you don't know where how to get to the internet, you even somebody command set up a command and tell you, okay, tell the others, you will not. Okay, that's the rule. So my understanding is correct though. The next is called DR and the BDR. DR is the designated router, and the BDR is the backup designated router. So what happened is, to see uh, you have a line, uh, local line, and on this line you have more than two routers. Actually more than one routers. Because all these routers are on the same local network, what I try to say is like this. To see if you have you have a to see if you have three routers here, right? So if you have three routers here and they are on the same network, so by default each one will advertise uh, the same network to the others. So it's kind of waste your bandwidth because three router will advertise the same information three times. Uh, so the idea is the three router will elect or designated router, and this router will advertise the this network. All the others will not. Um, and BDR basically is the backup. So if for some reason this DR dot died, the BDR will represent this local network. Let's see if we display OSPF peer. You should see you see on this network, even this only two routers on this Ethernet, because there's a gig interface, is kind of internet and they are on the same subnet. So to see on the serial port, they don't have this one, right? So you see DR, BDR, none, none. They don't need to do that. But for the Ethernet interface, you have DR. By default, is the bigger IP became the DR. So BDR start one. So this one is DR, this one is BDR. So, but we can change this behavior, less default behavior, right? So we can go to here, interface gig 000. We can see OSPF DR priority 200. So when we after we did this, let's see. DR, BDR, okay, still let's do something here. It doesn't come up, okay. DR, BDR. I'm not sure why it doesn't have it. I think it may takes take a while. Okay, now you can see. So DR became 10.0.13.1. BDR is the dot 3. Before is dot 3 is the DR. Before it is. See, before the DR is dot 3. Now the DR is dot 1 because we changed the priority. So that's pretty much everything we learned from this chapter. So thank you for listening.